Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Akmal bin Muhammad Faris and I will be presenting Group 1 for Assignment 3. The first design, iteration 1, we have first mass of 50, second mass of 75, first stiffness of 100 and second stiffness of 600. Applying that into its formula form, we get the first equation of 50x1 plus 75x1 plus 100x1 plus 100x2 equals to 0, and the second equation of 75x plus 600x plus 600x1 equal to 0. From both of those equations, we can get the matrix form of mass, which is 50, 0, 0, 75, and matrix stiffness of 700, minus 600, minus 600, and 600. We can get the general equation with the help of influencer coefficient, where the influencer coefficient is equal to 1 over stiffness, where in 1 over k1 it is 1 over 100, while for A22 it's 1 over k1 plus 1 over k2, which is 7 over 600. Substituting all the values into the equation, which can also be written in matrix form, where x1, x2 equal to w square 0.5, 0.75, 0.5, 0.875, x1, x2. Solving this equation will allow us to get x1 over x2, which is equal to w squared 2.25. With those values, we can go on and solve it to get natural frequency as well as its mode shape, which is in this case, the mode shape is 2.6875, 2.9687, while the first natural frequency is 1.639 and its other natural frequency is 1.723. Moving on to the second iteration, we have the mass still at 50, second mass at 75. Meanwhile, the stiffness both have been increased by 50, giving us the first stiffness of 150 and second stiffness of 650. Then we have the matrix form of it of mass, which is 50, 0, 0, 75, and stiffness matrix of 800, negative minus 650, minus 650, minus at only 650. To get the value of A, we have A11, which is equal to A12, equal to A21, which is equal to 1 over K1, which is 1 over 150. Meanwhile, A22 is equal to 1 over K1 plus 1 over K2, which is 8 over 975. We apply this into the formula and turn it into a matrix form. We get x1, x2 equal to w square 0.334, 0.5, 0.334, 0.615, x1, x2. Solving this will get us x1, x2 equal to w square 1.334 and 1.564. When you apply this back into the matrix, you will get the shape mode of 1.228 and 1.407, while its first natural frequency would be 1.108 and the second natural frequency to be 1.186. On the third and final iteration, we have both masses still at 50 and 75 respectively, while its stiffness being another extra 50, having 200 and 700 for K1 and K2, and thus leaving us with the matrix mass of 50, 0, 0, 75, stiffness matrix of 900, negative 700, negative 700, and 700. Applying this into the formula of x1 equal to a11 m1 x1 w square plus a12 m2 x2 w square, and its second formula x2 equal to a21 m1 x1 w square plus a22 m2 x2 w square, where a11 is equal to a12 and also a21, which is 1 over k1, which is equal to 1 over 200. Meanwhile, A22 is equal to 1 over K1 plus 1 over K2, which in this case is equal to 9 plus 9 over 1400. Applying these values back into the formula, we will get the matrix form of x1, x2 equal to w square 0.25, 0.375, 0.25, 0.482, x1, x2. Solving this, we will get x1, x2 equal to w square 1.214. Applying this back into the equation, matrix equation, we will get the mode shape of 0.705, 0.835, and the first natural frequency would be 0.840, and the second natural frequency would be 0.914. For the second design, first iteration, the masses are both still the same for 50 and 75, but the stiffness are both changed, whereas K1 and K2 are both equal to 600, leaving us with the matrix mass of 50, 0, 0, 75, and a stiffness of 1200, negative 600, negative 600, and 600. From this, we will get the formula x1 equal to a11 m1 x1 w square plus a12 m2 x2 w square, and x2 is equal to a21 m1 x1 w square plus a22 m2 x2 w square. The value of a11 is equal to a12 a21, which is equal to 1 over the first stiffness, which is 1 over 600. Meanwhile, a22 is equal to 1 over k1 plus 1 over k2, which is equal to 1 over 300. In the matrix form, this equation will equal to x1, x2 equal to w square 0.0834, 0.125, 0.0834, 0.25, x1, x2. Solving this equation, we will get 0.334 and 0.5834. If we apply that back into the formula of x1 and x2, we get the mode shape of 0.101 and 0.174. Meanwhile, the first natural frequency is 0.318 and second natural frequency is 0.417. For the second iteration, with both masses remaining the same, we have its stiffness increased by 50, giving us K1 equal to 650 and the same for K2, giving us the matrix stiffness of 1300, negative 650, negative 650, and 650. Using the general equation with the help of influencer coefficient, we get the value of A11, which is equal to A12, equal to A21, equal to 1 over K1, which is equal to 1 over 650, while A22 is equal to 1 over K1 plus 1 over K2, which is equal to 1 over 325. In matrix form, we can solve this equation. We get x1, x2 equal to w square, 0.077, 0.115, 0.077, 0.231, x1, x2. By solving this, we get 0.307 and 0.539, where we can substitute in back into the equation and get the mode shape of 0.086 and 0.148. Meanwhile, its natural frequency would be 0.293 and 0.385. For the third and final iteration, we get both stiffness at 700 and both masses staying at 50 and 75 respectively, giving us the stiffness matrix of 1 400, negative 700, negative 700, and 700. Input and the general equation with the help of uh, influencer coefficient of x1 equal to a11 m1 x1 w square plus a12 m square x2 w square, and x2 is equal to a21 m1 x1 w square plus a22 m square m2 x2 w square. The value of the influencer coefficient is a11 equal to a12 equal to a21, which is equal to 1 over k1, which is equal to 1 over 700. Meanwhile, a22 is equal to 1 over k1 plus 1 over k2, which is 1 over 350. Solving that equation, we will get x1, x2 equal to w square 0.285, 0.499. We substitute back that equation into the full matrix, we will get the mode shape of 0.074 and 0.127, and its natural frequency of 0.272 and 0.356. As you can see from the result of our calculation, the first design, we use the mass of 50 and master of 75, while the coefficient of stiffness ranges from 100 to 200, and the second coefficient of stiffness ranges from 600 to 700. The experiment is repeated 3 times while increasing the value of both stiffness up by 50. In the first design, you can see that on the third iteration we get the lowest first natural frequency and first mode shape on both stiffness. Meanwhile, on the second design, the value of first natural frequency and first mode shape is even lower than that of the first design. And that is on the third iteration, which is 0.074, 0.272, 0.127, 0.356 for its first natural frequency, first mode shape on the first stiffness as well as the second stiffness. That is all from me. Thank you very much.